Okay, so in the tech world, you hear the term system design thrown around all the time. But here's the thing, depending on who you're talking to, it can mean something completely, totally different. It's almost like a tale of two worlds all sharing this one name. So what actually is system design? Well, the answer really depends on who you ask. It all boils down to your role. Like, are you the person crafting the user experience, the whole visual feel of a product? Or are you the one building the massive digital infrastructure that makes the whole thing run? And here you can see the two sides of that coin perfectly. For designers, system design is all about creating a consistent visual language, the product's whole look and feel. We're talking fonts, colors, how things are laid out. But for engineers, it's about the architectural blueprints. It's about building this powerful, resilient system that can serve millions and millions of users without, breaking a sweat. See, two totally different problems, but they both fall under the umbrella of system design. So here's what we're going to do. We're going to dive into both of these worlds. First, we'll look at what I'm calling the visual blueprint, the designer side of things. Then, we'll totally switch gears and check out the architectural engine from the engineer's perspective. And, to wrap it all up, we're going to see how, believe it or not, they share the exact same end goal, building for massive scale. All right, let's jump in. First up, we've got the visual world. This is system design as a product designer sees it. The whole goal here? To create a user interface that's consistent, totally predictable, and, well, beautiful. A really great way to think about a visual design system is to picture a tree. The foundation. We're talking the absolute core values of your brand. Those are the roots. And it makes sense, right? If those roots aren't strong and super well-defined, the entire system you build on top of them is just going to be weak. It won't have what it needs to grow. So how do you actually build those strong roots? Well, the answer is a concept called design tokens. Think of these as the literal atoms of your design. They're the smallest possible pieces. A design token isn't the blue button. No, it's the specific hex code for that exact shade of blue. It's not the title font. It's the raw definition of the font family and its weight. They become the absolute single source of truth for every single visual thing in your product. And to manage all these tokens without going crazy, most pros use a three-tiered approach. It's actually pretty clever. First, you have the brand collection. This is just the raw, pure values, like a specific hex code for purple. Then you have the alias collection. This is where you give that value a job, a purpose. So our purple hex code now gets a name, like primary color. And finally, there's the mapped collection, which applies that job to a real component. For example, our button background now uses that primary color. It's this structure, this layering, that makes the whole system scalable and so much easier to maintain down the line. So what's actually in those roots, in that brand collection? Well, you'll find things like colors, and they're usually defined on a numeric scale. Think like purple 100 for the lightest shade, all the way up to purple 900 for the darkest. You'll also find all your font definitions, and this next one is absolutely crucial. You'll find a base numeric scale. It's often in multiples of 4, and this little scale governs all your sizing and spacing. It's what creates that perfect mathematical harmony you feel across the whole interface. All right, let's do a hard pivot. We are now leaving the visual world and entering the second world of system design, the architectural engine. So here, the challenge has nothing to do with visual consistency. No, it's all about building a digital machine, a service that's incredibly fast, super reliable, and can handle just massive growth. Every huge application you use today, think social media, streaming services, whatever, they didn't start out as these complex beasts. Not at all. They all began with the absolute simplest setup you can imagine, something designed to serve maybe just one single user. And that journey from one user to a billion users, that's really the core of what architectural system design is all about. So how does the system actually evolve? Well, it almost always starts with one single server that's doing everything. The web app, the database, the cache, it's all on one box. But then, as traffic grows, that one machine just can't keep up. So the first move is usually to split things up. You might move the database to its own dedicated server. But the real game changer, the big leap, is something called horizontal scaling. This is where you add a load balancer out front. You can think of it like a traffic cop, and its job is to spread all the incoming requests across a whole army of identical web servers. But that brings up a really critical decision, right? When you pull that database out onto its own server, what kind do you actually choose? And trust me, this is not a minor detail. This is a foundational choice that's going to shape everything about how your app stores, finds, and protects its data. Okay, so broadly speaking, you've got two main families to choose from. First, you have SQL databases. These are relational, which means they store data in really structured tables, kind of like a spreadsheet on steroids. Their superpower is data consistency, which makes them absolutely perfect for things where accuracy is key, like e-commerce or financial apps. Then you have NoSQL databases. These guys are way more flexible. They're all about speed and insane scalability, which is exactly why they're the go-to choice for things like social media feeds or huge big data projects. Now, what about the servers themselves? How do you make them handle more load? Well, here again, you've got two main paths you can take. The first is called vertical scaling or scaling up. This is pretty simple. You just make your one server more powerful. You add more CPU, more RAM. It's easy, but you're going to hit a hard physical limit eventually. The other option is horizontal scaling or scaling out. And this is what we were just talking about. You just add more servers to share the work. Yeah, it's more complex to manage, but its potential for growth is pretty much infinite. Okay, so we've looked at these two pretty different worlds, right? The visual blueprint and the architectural engine. On the surface, they use different tools, they speak different languages, they seem totally separate. But if you look deeper, underneath it all, they are striving for the exact same thing, to create a rock-solid foundation for growth. And this is where it all comes together. They share a core philosophy. Think about it. Both systems depend on having a single source of truth, whether that's a design token for a color or the main database for user data. Both of them are obsessed with consistency, making sure the experience is predictable. Both are built from the ground up for scalability, so the product can grow without falling apart. And finally, both aim for resilience, creating a foundation that is just really, really hard to break. So here's a little something to think about. The next time you open your favorite app on your phone, just take a second and think about these two invisible systems working together in perfect harmony. You've got the visual system, making sure every button, every pixel, every animation feels just right. And at the exact same time, you've got the architectural system in the background, flawlessly handling your data, your requests, everything. So how do these two systems, so different on the surface, but so similar in their goals, how do they come together to create that one seamless experience you're having? That is the real magic of system design.